Hey everybody, welcome back to another episode of the Ben Taylor podcast, the home of marine industry insights. Today we're talking about solar panels made specifically for boats. I'm sure there's a lot more to it, but we'll get into all that. So today I'm with Simon. Good to see you, Simon.
Good to see you, Ben.
So give us some context. What's the company? What are you guys about? What's the mission here?
All right, so open water solar, and we started off back in 2020 trying to design and build a 40-foot carbon fiber sailing catamaran that was all electric, zero fossil fuels on board. That was the rule.
Yeah.
It was a mission because it failed, and it failed.
It was a failed mission
because the solar that we put on wasn't very good.
And these at the time were kind of pretty typical solar panels that you see in everyday life outside of marine.
I'm an engineer, but I knew nothing about solar, nothing whatsoever.
Yeah.
And so I was like, why isn't my electric boat working? These solar panels suck.
Yeah.
And so I looked into it and realized three very distinct problems: microcracking, surface utilization, and bypass diodes.
Okay.
And so I said to myself, if we're ever going to have a business here and making these boats, then we better, and
this
more
is the
importantly,
biggest problem, isn't
electric.
it?
It was the only problem. The boat was a freaking machine.
Yeah,
and we were sailing at 20 knots in 22 knots of boat, like 22 knots of wind, 22 knots of boat speed. It was wild.
Fair enough. Yeah.
And so, but it wasn't all electric. We almost had to go sailing to charge the boat through hydro generation.
See, this is interesting. I mean, we've just had a conversation before saying for electric boating or fully electric boating, it has to be driven by the owner.
Absolutely.
As in, that owner's got to be a real die-hard, passionate individual about making sure it is that way. Otherwise, there will be other options which will be easier, and they will kind of take the lead.
Yeah.
So you were that passionate boater, basically.
I was that owner who said, you know what, I can't buy what I want, and so I'm going to build it, and I'm going to set up a company and do that.
Right,
and
here we
saying
go.
that, and all of our customers right now are those passionate boaters, like two Archipelago 80s that we're doing, 80-foot aluminum yachts, 24 kilowatts of solar, two heli deck on each. Both of those owners want to be fully electric, right?
Yeah.
And so it's got to be that drive and the passion.
Right, and talk us through that journey. So you kind of find it's a problem on your own boat, and then what's the stage one of starting open water solar?
Stage one was to conceptualize, can we fix those three problems? And so microcracking, the cells crack too easily, and the efficiency reduces.
And is that just from kind of the boat movement and kind of hitting waves and stuff? Was that enough? Or were you walking on it? Like
it was enough.
What are we talking about?
Unpackaging it from the box, picking it up, and installing it.
Right.
We now know that because we now have an EL camera, which is an electroluminescence camera, and we've bought some competitors' panels, and we've literally took them out the box with white gloves on, and they're already cracked from the factory.
Wow.
And so they're incredibly fragile. So people who say, yeah, you can walk all over them, you can, but you will crack them. And especially with boat movement, you'll crack the panels. And so that was the biggest issue. Second one was space utilization. And then the third one, I had a sailing boat, and we kind of have a lot of shade.
Yeah.
Right. So we needed to fix that shading issue by more bypass diodes, so we can eliminate the shaded cells from the circuit. So when the sun was shining on the cells, they were fully engaged and producing as much power as we could.
Okay, I think I've just understood what bypassing diodes are.
Right.
But basically they kind of turn off when there's not enough light to create enough electricity.
Exactly.
And then prioritize the other ones.
Yeah. So imagine it like the old school Christmas tree lights. One light goes out, they all go out, right?
And you can't find the light that's gone.
Exactly.
Yeah.
And the solar cells are the same, they're all in series. So one goes out, they all go out, right?
That's
unless
ridiculous.
you bypass that shaded circuit.
Yeah.
And so basically those were the problems. So being an engineer, I hypothesized and said, can I fix those problems? Yeah. And I'm a composites engineer, so I said, can I fix those problems by encapsulating solar cells in a composite laminate?
Okay.
We found about 1,000 ways on not to do it.
I'm sure.
And now we've found the way, and we're on about 40 boats, so we've done about 18 months of sort of field testing.
Yeah.
We've perfected the product, and now we're launching it here at Metstrade in 2025, which is super exciting.
Like this is the launch.
This is
like
the launch.
Go-to-market.
This is our go-to-market. We did when we first met back in 2023. We're in the startup pavilion, right?
Stand,
we were just doing a bit of customer discovery. Is this actually going to work? Do people want this, right? Since if you look at our products then, you look at the product now, This is our
I remember
product.
the sample. I
right?
remember the sample that you had years
And
ago. Yeah,
it's night and day difference
Yeah.
in terms of its aesthetic appeal, its quality, what we can do with it, and the boats that we can put on.
Right. Could you go into a bit of detail? So open water solar panel. What does it look like? I mean, this is a box of it. As there's a gripped version for the walk-in surface of the boat, and then a smooth surface for where you want it to be a smooth surface.
The side of the boat. So this
Right,
is
yeah,
this is a composite box that we built in our shop. This is what the side of the boat could look like, and this is what the top of the boat could look like.
Yeah.
This is a sample, because you can't see this very easy, of the non-slip. So this is an all-grip CS customizable sheen clear coat. So the all-grip product is second to none as a clear coat, and then with the all-grip non-slip embedded in it.
Right, and what's happening here? So you got a coating which gives it the grip, hence the texture and that feeling, but the light can actually just still go through this effectively enough
100%.
to produce enough.
Yeah, and we've done a little bit of provisional testing to show that because this is microscopic glass beads as the grip, so low angle light will actually come at an incidence and go into the panel a little bit better. And so that was a byproduct of it, and going, whoa, we get a really good low light efficiency here.
Yeah.
And so what that panel is made of is just strictly a highly modified epoxy resin, fiberglass, solar cells, and all grip clear coat. That's it. That's all we've got in it. No plastic, no EVA. A very unique method of manufacturing it. And now we're ready to go to town.
Okay. And so what's I suppose the target market for this? I'm going to guess and say, ideally, it'd be straight into OEMs, production boats, who align with that kind of vision of having a fully electric vessel, or kind of supported by solar.
Yeah.
Is that the ideal?
Absolutely. So we've got two real markets here. We've got the OEMs and we've got the service partners. So we've got customers who already own their own boats, and they really are done with running a generator, right?
Yeah.
So they're putting a Victron system on it, right? They're putting lithium batteries. Yeah. And they've now got the lithium batteries, they've got the inverter chargers, right? And now they've got the solar chargers, and now they've got an opportunity, instead of putting rigid panels on or the semi-flex panels that crack real easy, is to actually put a solar deck on it. And hence you can actually see our trademark is solar deck, because what we've realized is we've created a decking material out of this product.
Yeah.
And so we can literally customize any shape, any size, have maximum real estate utilization, and put a non-slip surface on it so you don't slip. And so just on that, we're actually doing one of the IMECA 60s ready for next year's Vendée Globe.
That's awesome.
So we're expecting to be on quite a number of IMECAs or IMOCAs for the Vendée Globe, because it's if there's ever an event or a race where you need power, it's that.
Yeah, true. Yeah, and reliably as well. I'm trying to think what's next for you. I mean, I suppose it's go to market.
Yeah.
It's go to market.
Go to market.
Make sure you can do it at scale.
Go to market and dominate the marine solar industry, because it's a very unique product. The aesthetics of it are off the chart, and it's a functional product. Like you can't slip on this product. It's super super grippy, and so you're walking around on the boat, race boat, whatever. One of the more interesting projects we're doing right now is an Archipelago 80. We're actually doing two Archipelago 80s.
Okay.
So these are 80-foot aluminum catamarans, but they're very unique because the 14-meter deck doubles as a heli deck. And so our customer is a helicopter pilot, owns a helicopter company, and we sent him one of our sample panels, and he landed on it.
I was going to say, did he?
And it survived. So no, we're not going to do the H in the middle, because that's kind of crazy. But you know what? If he screws up the landing and doesn't land on the H, and he lands on the panels, they're going to survive.
Would still be fine.
Absolutely.
Yeah. So this doesn't have to be a flat surface. So that could be, I don't know why you do this, but that could be wrapped around a mast or something like that.
It could be.
It could be fully
so
flexed
one thing about one thing we're trying to do here as well is educate people. And this is really important, because you just said, can we wrap this around a mast? Absolutely we can, no problem. Why would we do that? Solar cells need the same incident in the same circuit. They need to be the same incident to the sun. Otherwise, you always get the least performing cell dominates the circuit. So if you've got one cell pointing towards the sun and one cell pointing away from the sun, then that one cell pointing away from the sun is going to dominate the current in that circuit.
Right.
So when we're designing a system, we design it very specifically. So we've educated ourselves a lot on the intricacies of solar design. And like I learned when I just threw 16 solar panels on my 40-foot yacht, you can't just do that. You have to really think about it. You have to think about panel orientation. You have to think about string orientation, how the bypass diodes are positioned, what circuits are we using, what voltages are we using, are we doing series and in parallel? Right, and then that whole design parameter is different for different boats.
Yeah, so you need to be involved quite early in the design phase, especially if it's something like a production boat. It's when they're developing that model, it needs to be carefully considered where these panels are going to go, how it's going to integrate with the rest of the experience of the boat, as well as the manufacturing process.
Yeah.
Otherwise, because it's far from, okay, we've got a whole, we could retrofit them and say, well, you know, this stick on and that'll be all right.
Yeah.
But you could do so much more. You can go way further.
Yeah,
and actually integrate it into.
You really can, and you can really, in the design phase. Hence, we're talking to a lot of naval architects. In the design phase, this looks amazing, right? It's an amazing. Nikki calls it sexy solar, and it really is.
Yeah.
And because the aesthetics of it are off the chart. So when we're talking to naval architects, we can incorporate this into the design of the yacht to increase and enhance the aesthetics, but still giving maximum energy generation.
Love it. What's next?
What's next? We keep growing. So,
growing.
We're currently automating the manufacturing process. We're from Western Canada.
I was going to say, is that manufactured out in Canada?
And we're talking to 2 companies right now in Europe to by the end of 2026 to bring manufacturing to Europe, because you know what? This is where the boats are built. There's a lot of sailors here, and to be honest, there's a bigger demand. We've just talked about it. This has got to be driven from the customer, and guess where the customers are who want to save money. It's the Europeans.
They're really environmentally conscious.
100%. So where would we build a manufacturing plant? Yeah, we live in Canada. It's a beautiful place, right? We've developed the technology there, but we're going to build it where our customers are.
Yeah, a lot of boats are built in Poland, in Italy, France. Yeah. Okay,
exactly.
Awesome. Simon, thanks for coming on the podcast.
Awesome. Cheers, Ben.
I've learned a lot. I love it. I love seeing your journey as well. That's awesome. And best of luck throughout Metstrade and the years to come.
Thank you.
Everybody, if you enjoy content like this, make sure you're following here to see plenty more of it. All being well, I'll see you again next time. Bye for now.